Hi student, how are you? Today's topic is the addition rule for probability. Please memorize the important formula. Probability of A and B is equal to probability of A intersect B. And probability of A or B is equal to probability of A union B. So N A and D, there's an N between A and D. So remember, intersect A and B. Okay, N means you have to use an intersect. Okay, for all, we use union. The addition rule of probability is probability of A union B is equal to probability of event A plus probability of event B, or probability of A union B is equal to probability of event A plus probability of event B minus probability of A intersect B. Okay, so this is for mutually exclusive and non-mutually exclusive event. The addition rule for probability: event A and B are non-mutually exclusive events. So there is intersection between set A and set B. So the formula for non-mutually exclusive events is PA union B is equal to PA plus PB minus PA intersect B. Whereas for event A and B that are mutually exclusive events, so the probability of A union B is just equal to probability of event A plus probability of event B, because for mutually exclusive there is no intersection between the two sets. Okay, again, event A and B are mutually exclusive event. So the probability of event A or B is just equal to probability of event A plus probability of event B. Event A and B are non-mutually exclusive events. So the probability of event A or event B is equal to probability of event A plus probability of event B minus probability of event A intersect with event B. Let's discuss the example 7. The Venn diagram on the right shows the relationship between the universal set A, B, and C. A number is chosen at random from the universal set. Verify the addition rule of probability for each of the following combined events. For A, obtaining an even number or multiple of 5. Let's discuss this. First of all, we draw the Venn diagram to show the relationship between the universal set, okay, and set A, B, and C. So obtaining an even number or multiple of 5. So even number we have 2, 4, 6, 8. And multiple of 5 we have 5 only for set B. Okay, so event to obtain an even number or multiple of 5 is write as PA union B. So I highlight the A union B with blue color. So the number of A union B, we have 5 elements, and total number of sample space we have 9 elements. So the probability of A union B is 5 over 9. Okay, then the probability of event A plus event B, we take event A, we have 4 elements out of 9, and event B, we have 1 out of 9. The probability of event A and event B, when you add together, is also 5 over 9. So hence, it is proven that for probability of A or B is equal to probability of event A plus probability of event B. Okay, for the same question, we will do B, obtaining an even number or a prime number. Okay, for this case, probability of event A or C is equal to number of event A or C over number of sample space. So A or C, it means A union C. So there are 7 elements for A union C. So the probability of A union C is 7 over 9. So probability of event A plus probability of event C minus probability of event A intersect with C is equal to 4 over 9 plus 4 over 9 minus 1 over 9. So the answer is equal to 7 over 9. So hence, it is proven that for probability of event A or C is equal to probability of event A plus probability of event C minus probability of event A intersect with C. Let's see another example. 8 cards labeled with the number 4, 5, 6, 7, 8, 9, 10, 11 are put in a box. A card is chosen at random from the box. A is the event of getting a number greater than 8. B is the event of getting a prime number. C is the event of getting an even number. So, first of all, we need to list out A, okay, greater than 8, we have 9, 10, 11. Set B, we have prime number 5, 7, 11. A union B, we have 5, 7, 9, 10, 11. So the probability of A union B is 5 out of total sample space is 8. So, okay, if we use a formula, probability of event A or B, A union B is equal to PA plus PB minus PA intersect B. So the answer is 3 over 8 plus 3 over 8 minus 1 over 8. So the answer is 5 over 8. Hence, it is given that probability of event A plus probability of event B minus probability of A intersect with B is equal to the probability of A or B, or we can call as probability of A union B. Let's discuss question B, probability of event A or C. Okay, first step is you list out A. A is a set consists of number greater than 8. So we have 9, 10, 11. Okay, C is event getting an even number. Even number we have 4, 6, 8, 10. So probability of A union C is 4, 6, 8, 9, 10, 11. Okay, so total number of elements in A union C, we have 6 elements. So probability of event A union C is 6 over 8. So simplify, the answer is 3 over 4. Okay, so if we use a formula, probability of event A plus probability of event C minus probability of event A intersect with C, so we will get 3 over 8 plus 4 over 8 minus 1 over 8, which is 6 over 8. Simplify is 3 over 4. So now it is proven that probability of event A plus event C minus probability of A intersect C is equal to probability of event A or C. Okay, let's discuss question C. So still referring to the same sample space 4, 5, 6, 7, 8, 9, 10, and set A is number greater than 8, set B is prime number, set C is even number. In order to find probability of B or C, okay, first step, list out the set B. Okay, set B is prime number 5, 7, 11. Set C, even number 4, 6, 8, 10. So B union C is equal to 4, 5, 6, 7, 8, 10, 11. So the probability of B union C is equal to 7 out of total sample space is 8. Okay, so the probability of B or C or B union C is equal to probability of event B plus probability of event C, which is 3 over 8 plus 4 over 8. So the answer is 7 over 8. So hence it is proven that probability of event B plus probability of event C is equal to probability of event B or C, which is represented by probability of B union C. Okay, students, I prepared 3 questions for the homework. I try to discuss one question. Okay, the other 2 you need to do on your own. So today I will try to help you to do question 1. Let's see the question 1. 2 fair dice are rolled simultaneously. Q is an event that the total point obtained from 2 dice is greater than 9. Meaning what? Meaning that let's say you getting 4 for the first dice. For the second dice, maybe you get 6, 4, 6. Okay, that one is considered one of the events that greater than 9. Okay, total means you plus 4 plus 6 is 10, more than 9. 6, 4 also can. Okay, that's Q. For R, is an event that product of the point. Product means multiply. Okay, you multiply the point. For the 2 dice is a multiple of 5. That means multiple of 5 means 1 times 5, so 1, 5. Okay, 2 times 5 also can write 10. 10 is a multiple of 5. 3 times 5 also can. Okay, 3 times 5 is 15. 15 also multiple of 5. Okay, 4 times 5 also can. 20 is a multiple of 5. Okay, that is the meaning of the event R. S is an event that 2 equal points on the 2 dice are obtained. Equal point means, let's say you first dice you got 2. Okay, second dice also you got 2, 2, 2, or maybe 1, 1, or maybe 3, 3. That is so called 2 equal points. Okay, so we will do A. Q or R means Q union R, probability of Q union R. Okay, and then Q union S and probability of R union S. So let's see the next slide. Hi student, let's roll the 2 dice. Okay, so please observe the possible outcome. Cool. The number, there is no number on the dice, but the dot, one dot represent 1, 2 dots represent 2, 3 dots represent number 3, 4 dots represent number 4, 5 dots represent number 5, 6 dots represent number 6. So if you roll the 2 dice, how many possible outcome? Okay, please list out the sample space. Okay, students, for cases like this, due to too many elements in the sample space, So I advise you to use a table. Okay, the table you draw must have the dice 1 and dice 2. Okay, the dice 1 I use a red color, 1 2 3 4 5 6, and then the other one I use 1 2 3 4 5 6, but I use green color. Then I just list out the green color, okay, vertically, and the red color number horizontally. Then I can calculate the sample space very fast, which is 6 times 6, right? So number of sample space is 36. Okay, so it's very systematic. So in future, if you notice that you got too many elements in the sample space, so try to use a table to list out. Then only you write down using set. Make sure you put braces when you list out the sample space. Okay, so based on this table, we are going to answer the question. Okay, students, let's discuss this question. So the one that I circle in red color, okay, is event Q. Event Q is the total point obtained from the two dice greater than 9. So it can be 4, 6, 4 plus 6. Total you plus 10. 10 is greater than 9. 5 plus 5, also 10, greater than 9. 5 plus 6, 11, more than 9. 6 plus 4, 10, more than 9. 6, 5, 6, 6. Okay, these are the event Q. Okay, and then for event R is a product of the points obtained must be multiple of 5. So that means it can be 1 times 5. 5 is a multiple of 5. 2 times 5, 10, multiple of 5. 3 times 5, 15, also multiple of 5. 4 times 5, 20 is multiple of 5 also. Or the other way around, 5 times 1, 5 times 2, 5 times 3, and 5 times 4. So total we have 14 cases. We have 6 cases from Q, and we have 8 cases or 8 elements for event R. So union we just plus. So 8, okay, plus 6, so you have 14. Total sample space will be 36. Okay, multiplication rule, 6 times 6, 36. So your answer should be 14 over 36, and simplify your answer to the simplest form will be 7 over 18. Okay, understand? Good. Now the one highlight in yellow color are the possible outcome for the question A just now. Okay, so you can observe the yellow color. I have total which is more than 9, 4 6 5 6 6 6 6 5 5 5. Okay, then I have the multiple product of the two dice which is multiple of 5. I have 5 1 5 2 5 3 5 4 5 5. I also have 1 5 2 5 3 5 and 4 5. Okay, and 6 5. All right, 6 5 5 6. So union we take in all the elements. If repeat one, we take once only. So if you count, they are altogether 14 cases. So the answer that you show from the table is very clear. Okay, so you can try to use a table so that we won't make careless mistake. Alright, you have to list out your answer, list out the event in the braces. Okay, use a set. Okay, representation by set notation. So let's discuss number 1b. Find the probability of event Q union S or Q or S. Okay, so first of all, we have to identify the event Q. Like just now, total point more than 9. We have 4, 6, 5, 5. The one in purple color, 5, 6, 6, 4, 6, 5, 6, 6. So we have 2, 4, 6 elements in event Q. And for S, okay, 2 equal point on 2 dice. So we have 1, 1. The one I take in red color, 2, 2, 3, 3, 4, 4. Okay. So 2 equal point that I obtained. So we have total 10. 6 and 4, 10 out of 36. So simplify to the simplest form will be 5 over 18. So from the table that I highlight in blue color are the event that so the table that I highlight in blue color are the event that Q or S. So from the table it shows clearly you have 1, 1, 2, 2, 3, 3, 4, 4. You have 5, 5, you have 6, 6. You have 4, 6, 5, 6, 6, 5, and 6, 4. Okay. Total you have 10. Okay, you have 10. So out of sample space will be 36. So 10 over 36 or equivalent to 5 over 18. So 1C, probability of event R or S. So for event R, I take in blue color. Okay, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 6. And for event S, I take in orange color. 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5, and 6, 6. So union, so we take in all the elements. So the total number of elements for R or S is 16. So the probability for R union S is 16 over 36. So answer that you simplify to the simplest form is 4 over 9. Okay, from the table, the one that I highlight in orange color are the events for R or S. Okay, so I highlight 1, 1, 2, 2, 3, 3, and then 4, 4, and then 5, 5, and 6, 6. Okay, and also the multiple of 5, which is 1, 5, 2, 5, 3, 5, 4, 5, and 6, 5. And 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, and 5, 6. Okay, so from there, we won't miss out any of the elements. Okay, so I suggest for question like this, please use a table to solve to avoid careless mistake. Okay? Okay, student, this is another good question for you. So you need to try this and send to me through my email account. So this is the answer for question number 2. A, 2B, and 2C. Please double check your answer. Okay, student, this is the third question for you. Please read the question carefully and try it on your own, and then send your answer to my Gmail account. So this is answer for question number 3. Please double check your answer. Students, that's all for today. So please enjoy doing maths at home. Have a nice day. Bye. See you soon.